All right, today's lesson is the Pythagorean Theorem. Investigation 2. So we're going to talk about legs and hypotenuse. Legs make up the right angle. The side opposite the right angle is called the hypotenuse. And so the Pythagorean theorem says if you square each leg and add them together, it adds up to the length of the hypotenuse squared. So we're going to try that. We're going to build a square on this because it said the square, right? So 3 times 3 would give me 9. A square on this leg would give me 16. And a square on this one would give me 5 by 5 would give me 25. So let's check. The Pythagorean theorem says the sum of the squares of the legs equals the square of the hypotenuse. So that means you add these together. Does it add up to the hypotenuse squared? Is 9 plus 16, 25? Give me a nod if you think you agree. Yeah, 9 plus 16 is 25. So that's what the Pythagorean theorem says. If a triangle is a right triangle, you can square the legs, add them together, it equals the hypotenuse squared. So the short and easy formula that we learn is a squared plus b squared equals c squared. What does the theorem say, class? Get ready?
A squared plus b squared equals c squared.
Very good. So that's just leg squared plus leg squared equals the hypotenuse squared. So let's try this one. If I have a leg of 6, a leg of 8, what is my missing side? Let's square this leg. 6, so it'd be 6 long and 6 wide, so 6 times 6 is 36 centimeters squared. We'll square the 8. I'm trying to make it proportionate so they look the same, 8 and 8. That would give me 64. So what is the area there? So just we'll do the area first, then the side line. Well, the theorem says add them together. So let's add 64 plus 36. 4 plus 6 is 10. 6 plus 3 is 9 plus 1 is 10. So I've got 100 centimeters squared. Therefore, what would my side length be? Colin?
10.
He says 10. How did you get 10?
Because the square root of 100 is 10.
Oh, I love the language he used. He said he took the square root of this to get the side length, which is 10. So if I had some weird number in here, I would just take the square root, whatever it is, 53 or 52 or whatever. I'd take the square root, and then that would be my side length. Let's look at that triangle. It's a 6, 8, 10. Does it look like proportionately 6, 8, and 10? Yeah. What if I made a mistake and I said, Mrs. Boone, it's 6, 8, 100? Does it look like it could be 6, 8, 100? No, I have students that do that sometimes. They're like, I got it, it's 100, Mrs. Boone. Could a hypotenuse be 100 if this is 8? I mean, it's got to be just a little bit more than 8. It's just a little bit longer than 8. If you were to fold it down, it's just a little bit more than 8. So don't forget, square root your area. There's your 10 centimeters.
What about the...
All right, let's find this missing side. So if our hypotenuse is 13, and our leg is 12, and our other leg we don't know, how do we use Pythagorean's theorem for this? Okay, hold your. Some of you see it real quick. Some of you don't see it yet. Let's build our squares. Let's do a big 13 by 13. It's not perfect, but it's pretty close. Try to make it a square. 13 by 13 is going to be 169. This one's down here. This one's 144. So this little square, what is that? And how could I find out? Let's think. Pythagorean's theorem says square that and square that and add them. But I don't know what it is. But I know that these two added together equal that. Aubrey.
5.
She says it's 5. How did you get 5?
Because I subtracted 169 from... Wait. Yeah.
144 from 169.
Yeah.
9 minus 4 is... 6 minus 4 is... Okay, so 25 is the area. How did you get the 5 though?
You square rooted it.
You square rooted it. Very good. So, and I don't have units up here, but that's how you would do it. So be careful. Sometimes this is missing. So don't try adding. That's the other mistake students make is they try adding these two. No, these two get added to equal that. Okay. Here's a sample RISE test question on your standardized test at the end of the year. The reason why students struggle a little bit on this one is because they can't picture it in their mind. They always ask me, I don't understand this one. A ladder is needed to reach 7 feet high and must be slid away from the wall a distance of 2 feet for safety. How tall must the ladder be? So let's picture it. A wall, so there must be a ground, right? And then there's a ladder. Well, don't walls and grounds meet at a right angle? I have a right triangle. So I can use Pythagorean theorem. But let's put in the other information, 7 feet high. So from here to the top of the ladder is 7 feet. It didn't say the ladder was 7 feet. It says it has to reach 7 feet. And then the distance from the ladder to the wall has to be slid away. So there's our other 2 feet. So couldn't I simplify this and go, it's just the right triangle. Okay, let's use Pythagorean theorem. I need some help. Whoops. Here's a square. Here's a square. What are my 2 areas? How about this one? Preston. What would my area of this square be? 4. 4 feet squared because it's 2 times 2. What's the area of this square, Liesel? 49 feet squared. Good. Nice job with your units. So then, therefore, what would this one be? What's the area of this? We don't have the side length, but can we use these 2 together? Joseph?
45 feet squared.
40, careful, make sure you're adding. Here's our legs, so make sure you add the legs. 53, good, 53 feet squared, that's the area. What's my side length? Okay, Spencer.
The square root of 53.
I love it. It's an irrational number, the square root of 53 feet. But we're going to go down to Home Depot now and tell the guy, hey, can you cut me a root 53 foot long board? Or ladder, sorry. I need to buy a ladder that's root 53 now, so let's figure that out. Who's got a calculator? How long of a ladder do we need, Colin?
7.2.
7.2, so you just typed in root 53, and it might round up to 3. So maybe we should buy an 8-foot ladder to make sure we're tall enough, but that's how tall you have to hit 7 feet. Carpenters use this all the time to make a square wall, like that inside corner of our classroom wall. They'll measure out so many feet, like 3 feet, 4 feet, and make sure Pythagorean theorem works. That's how my husband did carpentry for like 10 years, and that's how he'd make square rooms. He'd measure out, and he'd keep adjusting the wall until he had a hypotenuse that worked with the Pythagorean theorem.
Wow.
Okay, Preston?
How do you know when to add and subtract?
How do you know when to add or subtract? That's a good question. Because the theorem says leg squared plus leg squared equals hypotenuse. So it depends on what you know. If you know this and you know this, you'll have to subtract. But if you know this and this, you add. Make sense? Okay. I forgot to put squared. All right, so Pythagorean triples. These are common numbers that work on triangles. You'll see them on the ACT test in high school. So there's a few that we just memorize because you see them a lot. And that's the 3, 4, 5 triangle. Here's your shortcut. 3 squared plus 4 squared equals 5 squared.
Wow.
9, 16, 25. 5 squared plus 12 squared equals 13 squared. The biggest one is always your hypotenuse. 8 squared plus 15 squared equals 17 squared. So these are some common ones. And not only that, the multiples of each of these triangles work. So if I were to times this whole triangle and double the size of it, wouldn't I get a 6, 8, 10? Well, that's going to also work for Pythagorean theorem. Squared, squared, squared. Right, 36, 64. Can I triple it? Times 3, times 3, times 3. And I'd get a 9, 12, 15. That's another triple. So if the question number 7 says, name a multiple of one of these triples, you would just times it by 2. Okay, these are called Pythagorean triples. What are they called? Get ready?
Pythagorean triples.
Pythagorean triples. I need a little bit more wakey upness from you guys, some wacky, energetic stuff like this. Come on in. Okay, so show me and say with me, slant.
Slant.
Very good. Sitting up straight, leaning in, not leaning back, eye contact, nodding as we understand. All right, so we talked about if it's a right triangle, then a squared plus b squared equals c squared. But the converse is also true. If you find any old triangle and you're like, oh, I wonder, is it a right triangle? And I've got these dimensions right here, and you're wondering, is that a right angle? Well, the theorem says if 5 squared plus 12 squared equals 13 squared, if that is true, then it is a right triangle. So we're going to replace this with a general rule, which ends up being true for that one. I memorized that one. A squared plus b squared equals c squared. If this is true, then it is a right triangle. That's the converse. Just stick it in the hole. Write that down in your notes as soon as you look up at me. I'll know you're ready to go. This is the converse. And I should put the word if. If a squared plus b squared equals c squared, then it must be a right triangle. Okay, awesome. All right, I see lots of eyes on this side. I've got Avery and Rachel and Colin and Ethan, Emma, Holden, Aubrey, Michelle, Preston, Joseph, Lindry, Hannah, Spencer. Now I have Jasmine. Okay.
I've been looking at you.
Question. Cassie, sketch a triangle and carefully measure the sides. Is your triangle a right triangle? I put never trust the appearance of a drawing. It looks right, doesn't it? I mean, some people say, can't you just hold up a paper to it, Mrs. Boone? And if it's like right there on the corner, it's a right triangle. Well, it looks right, but let's prove it with evidence, with mathematical evidence. We've got a theorem that says if a squared plus b squared equals c squared, then it's a right triangle. So will you write for me on your papers? A squared plus b squared equals c squared, or 7 squared plus 7 squared, and tell me if that equals 10 squared. We're going to take a vote in 20 seconds, and you're going to say yes, it's right, or no, it's not. Is the leg squared plus the leg squared equal to the hypotenuse squared? Okay, put your pencil up when you've got it, and you know your answer. All right, let's pick on Holden. What do you think, yes or no?
No.
He says no, prove it mathematically.
7 squared is 49.
Okay,
And also 7 squared is 49.
okay.
If you add 49 to 29, it only gets 98.
Okay, so 49 plus 49 gives us 98. What is it supposed to be?
100.
It should have been 100. So because these add up to 98 instead of 100, then this, I'm going to put a big extra, it's not a right triangle. Okay, that's how you use Pythagorean, is the converse. Yes?
It's an obtuse triangle.
It's just a little bit bigger, or is it a little bit smaller?
No, it's a little bit bigger
A
because
little
if
bigger?
it
Oh yeah, because this one is 100. If it was 98, this would have to shorten in a little bit to be 98. To make this dimension a little bit smaller. So good observation. Very good. We're going to do something like that later in the year too. Desk is fine. Find A in the right triangle below. Well, here's the right triangle. Leg squared, 1 squared plus leg squared, 1 squared equals hypotenuse squared, a squared. So 1 squared is 1, 1 squared is 1 equals a squared. What is 1 plus 1 is 2. So my square area here should equal 2. What is just A? Well, I'm going to square root both sides. Those are canceling each other. And the distance of A is root 2. It's an irrational number, and I certainly can leave it like root 2. It has a value 1.41-ish, but root 2 is just fine. Preston.
If we knew what A was, but didn't know what one of the legs was, we would have subtracted.
Yes. Yep. Very good. Okay, last one, we're going to do a quick graph, and then we'll get to work on our problems. So, up to this point, you might have been given a graph and said, how long is this segment? But they would have always put it on straight up and down or left to right. So you could have counted 1, 2, 3, 4 units. Okay? And 1, 2, 3 units. But you can't count this one because a unit's not there. It's not lined up anywhere. We don't have an exact unit to measure how far it is. So we know it's a right triangle because it's on a grid, right? Pythagorean theorem. Leg squared plus leg squared equals hypotenuse. So boom, leg here, 9. Leg squared here, 16. Add them two together, 16 plus 9 equals 25. So this guy, the area is 25. Therefore, what is my side length? Let's do it as a class. I think you guys know this. You ready? 5. Very good. 3, 4, 5. It's a Pythagorean triple. It's one that we memorize. A multiple, if I blew this up twice as big, it'd be 6, 8, 10. If I tripled it in size, 9, 12, 15. But I could do that, right? Just so you guys know that you'll see that. When I say go,